Just give me a second. Yeah. Yes, it is. Sorry, I didn't know. I didn't know. Okay.
Okay, class. You just take note. I'll be going through this on Friday. Okay. But I trust that most of you have completed around 3/4 of it, right? Okay.
I'm done with it.
Then your weekends can be. Last question. Yeah. Okay. Today is sort of the last part of this topic. Then next time I see you next week, we will be going to the lab one more time before the term ends. And after that, we will do chemistry. Okay? Okay, may I get you to flip to this page? There's fluid density. Okay, can you take out your textbook? Thank you. Right? Okay. Okay, a few things we're going to do today. We're going to learn about a new formula. I know it looks like math, but it is really science. Okay. Okay, so first and foremost, these are the learning outcomes for today. First one, we're going to learn how to calculate density. Then we will see the relationship between 3 different units. And finally, this last part, we'll be going into the practical lesson next week. Okay, I just want to check again. In primary school, you learn about this word called density. Okay, so you learned about it, but you don't know what the formula is. Okay, so just very quickly, may I just hear from some of you, what is density to you? Yes. Oh, okay. So density, the ability to float. Okay, I just realized this looks like a G, like ability to float. Okay. Ability to float. Okay, anything else? Okay, so what do you think? Okay, kind of based on how much it weighs. Okay, another definition here. Say again. Okay, amount of mass packed into your same space. Okay, into different sizes. Sorry? Oh, 1 minute. Wow. Is that slow or fast? Okay, Kartik? How dense an object is? When we say density, when I ask you what density is. Okay. I don't know what to write. Okay. Thanks, Kartik. how dense an object is. How dense an object is. Okay? Then
How is the molecules of metal packed?
okay, how is the molecules of metal? Then you say packed together. Okay. Anything else that you learned from primary school or you heard from here and there? What's up? Oh, ability to float or sink. Okay, last one. Oh, okay. Why do you say it's not about how it's packed, but it's about how big or small it is? Okay. Why do you bring up the size? Why does size matter? Okay. Okay. Different molecules have different characteristics, so you think it has to do with characteristics that affects the density. Okay. I will show you, or rather in your textbook, you will see the definition of density. Okay, let's try to make sense of it together. Right? Again, as a secondary school student, most things have been provided to you. The main thing you have to do is to highlight and underline or to include whatever is new to you. Let's look at the definition of density. Density is defined as a substance's mass per unit volume. What does that mean? What's the page? Can someone say what's the page? Okay. It says density is defined as a substance's mass per unit volume. What does that mean? Sucha, what do you say? Yeah, so there is a formula, mathematical formula for it, which is in your textbook. Your textbook phrases it in a slightly different way. For me, I wrote it in one straight line. Density equals to mass slash volume. This slash means divide. Okay? A fraction. So you look at your textbook, it's actually the same thing. It's that in your textbook we wrote it in a fraction way. Both are okay. Okay, I'm going to write down on the whiteboard what this means in simple terms. Density is defined as a substance's mass per unit volume, or in other words, it is defined as how much mass there is for every unit of volume. How much mass there is for every unit of volume? What do I mean by that? If I have, let's say, okay, I found two spheres roughly of the same size. One is a styrofoam, one is marble. I think intrinsically you know that one of them is going to sink in water and one's going to float, right? And if I were to ask you another way of asking this question, I ask you, which one do you think is denser? Your natural instinct will be to say that a marble is denser, right? Because it will sink while this one will float, right? At this level of secondary school, there's another way to look at this. When we compare a marble and a styrofoam, the reason why we would say a marble is denser is because there's a lot more mass packed into this same sphere compared to this styrofoam. You know, a styrofoam is quite airy. Yeah? Yeah. So density is really about how much mass you pack into that same space. Here, space for space, when these two are the same volume, actually this one is denser because I packed a lot more mass in this compared to this. Xavier?
But if you were to squash a marble into a flat piece of paper, wouldn't it still float because the mass has more room to spread out?
Oh, okay. If you say I crush this marble, is it?
Or your bed, it becomes like a thin piece of paper.
Okay, that's a good question. If I somehow were to be able to flatten this marble, will it change the mass?
No.
Remember, mass shouldn't change because of the shape, right? But will the volume change if I flatten this?
Yes.
amount of space it occupies. Okay, but if we were to do the math behind it, if I were to flatten this somehow, yes, Samuel? Okay, I'm saying in theory. Okay, but let's say if I really wanted to flatten it, one way to do is I have to melt the glass first, high temperature, then I can really flatten it. Oh, there's no air. So when I say I flatten it, I'm really just changing its shape. Yeah? I'm not squeezing air out, I'm just changing its shape. So actually, would the volume of this marble change if I flatten it? Yeah? I'll come to you in a while. Yeah? Okay, the marble, if I were to flatten it, the volume shouldn't change. Yeah? The volume really shouldn't change because it's still going to occupy the same amount of space, just a different way it's occupying the space. One in a spherical way and then one in a flat way.
But would it still
Yes?
But okay, let's say like you have more plasticity. If you flatten it, its volume changes.
Does it?
No.
Okay, that's a good question though. Okay, how might we prove that the volume of a plasticine ball has truly changed or not changed? Can you think of an experiment that we can conduct to figure out?
You throw the plasticine in water.
Okay, if we use the mass balance, what are we measuring? Mass. Does that prove whether the volume has changed?
No.
Okay, that will prove one thing though. If I were to squash a plasticine, and before I squash the plasticine, I wait. After I squash, I weigh again. And if the mass is same, it has proven that squashing it doesn't change the mass. How might we prove that squashing a styrofoam ball does not change the volume? Oh, sorry, a plasticine ball. So let's say I have a plasticine ball, then I squish it. So what experiment might we do to prove that the volume change or doesn't change? Okay, yes? Okay, perhaps I put a jug of water. Is there an instrument we can use to more accurately measure? Okay, yes? Beaker. Okay, so a beaker versus a measuring cylinder. From now onwards, use a measuring cylinder. You know what a beaker can do? It can measure volume, but its readings are very far apart if you pay attention. Can measure volume. But this will be a little bit more accurate. So let's go on this experiment a little bit more. As you were saying, how can I make use of this measuring cylinder? Okay, step by step. What should we do first? Okay, let's fill it with water to the brim.
Why don't we just put it half full and then see how much?
Okay, same here. You want to add on?
Can I illustrate on the board?
You want to illustrate on the board? What do you want to illustrate?
Fill the beaker. Wait, the beaker is the bigger one, right?
Okay, yeah. So let's use the measuring cylinder.
Never mind.
How to prove that the processing did not change volume? Yes, Samuel.
They add the same amount of water.
What is the same amount of water?
It's like let's say you put 500 ml of water and then like you just put the marble in first and then you add the same amount of water and if the result is the same means the volume.
I thought we were using plasticine.
Okay. So you're saying we add the plasticine first,
Yeah.
then we add the water after.
Yeah.
And then what will you prove if you add the water after?
Only me and the beaker, yeah.
And then must take it out later. Yes? Yeah. Okay, let's try. Two measuring cylinders. Fill both with 500 ml. Assuming that my measuring cylinder. Okay, so assuming my my measuring cylinder can take 500 ml as half. Okay, anything else? Next. Okay, plum. This one goes in. And then what do you expect to happen? Okay, you think the water level will increase, so let's say it increase. Okay, so now I need to take another similar ball shape, and then this time I squish it, and then I dunk it in.
Then you make it same.
And then we see it rise again.
So the same.
And now what?
And then you see whether the amount, the after like this, the glass,
Okay, Sophie, you want to add something? Sophie, the whole time when Yaya was describing, she was like trying to act the whole scheme out. Okay, yes. Okay, so what would you prefer? Okay. Yeah. Yeah. Okay, so the main difference here is that one, we use the same ball because you cannot guarantee that the second ball will be exactly the same. Okay, fair enough? Fair enough? Okay, then you will flatten this one and you reintroduce it into the water. But the key similarity between both is that if we find that this part over here is the same, that means the volume didn't change. Okay, but if this volume here and here is slightly different, that means there's a change in volume. Okay? Okay, how about this? Next practical, I'll bring some plasticine, then we try out. Then we see for sure whether our experiment works or not. Yes? Okay, does plasticine absorb water? I don't know. Okay, how about I bring some plasticine next week? You all try this experiment out, then we see. After we flatten, does the volume change?
Don't hurt my own girls. Don't hurt my own girls.
I bought yeah, they sell styrofoam molds like that. You thought I styrofoam block then like half not that much time Okay. Okay, so next week although our practical is purely about, we actually have a practical worksheet, but I'll bring extra styrofoam plasticine, then you can test this theory out. Okay? Yes.
Is plasticine oil-based?
Yes, it's oil based. Okay, I'll back to you. Okay, so what is density? Density is how much mass you can pack into a volume. So for example, if I were to show you now two volumes of the same volume, two balls of the same volume. Wow, I blew over this slide. Two balls of the same volume. Alright? You know what volume is? Okay. Two balls of the same volume. If I were to say that this ball is denser, this is what it may look like on a very small scale. Okay? That means to say that I am packing a lot more mass. Ayo, this will take very long. Okay. A lot more mass in one compared to the other. Okay? So that's what density is. And if you pack a lot more mass in one volume compared to the other, this would be denser. Yeah, but no, whether it's sink or not depends on the liquid you're putting in. For example, yeah. Okay, so in theory, let's look at all your friends' definitions here. Ability to float or sink, it is related, which we will look at later on. It is related. Isaac? I would say density, buoyancy, they are related to each other. Yeah? Buoyancy focuses more on the floating, more than the sinking. Okay, so ability to float or sink, it is related to density. Based on how much it weighs, and if you are talking about how much mass there is, then yes, how much mass that you can pack into different sizes. I like Daryl's definition, right? His definition was actually almost there. In fact, you can almost say that Daryl has a definition of density, just in a very more understandable way. How the molecules of the metal are packed together. Okay, I have to say that at this level now, as we slowly dive into chemistry, this word how is a little bit problematic if you want to use it in this context. How the molecules of metal are packed together, we will see that more in chemistry. It doesn't quite relate so much, but it's related a little bit to density. Right? For us, we are more focused on the mass. How much mass? How much mass you can pack into a certain volume. We have a particular definition that can help us understand density a little bit better. Because if we want to look at how much mass there is per unit volume, we can actually express that in a very elegant formula that goes as density equals to, so if you see this math, actually makes some sense. how much mass there is for every volume that you find. Okay, that's the purpose of this formula. In science, every time we have a formula, it is based on a scientific theory. Okay? It is not just a random plus, minus, times, divide. When we write mass divided by volume, we are saying density equals to how much mass per unit of volume. Water.
The water itself.
Oh, so that means to say, even water has a density of its own. Yeah. So now water has a density of its own. So we can calculate the density of water, and that's something we're going to do next week also. We'll find out what the density of water is. Yes. Oh, I think you are having a slightly different understanding of what density is. Perhaps we'll do some examples, then you'll see how this formula comes useful, and I can show you that you can calculate density of anything using this formula. Okay? So, we try out. This is the formula of what it looks like.
No, not this again.
Okay? In primary school, you all just learned this triangle before.
Speed and time distance.
So you all understand how this triangle works? Sorry, I don't want to look down on you all, but you all learned times divide before, right?
Yeah.
Okay, so mass, and then there's density, volume. Okay, I just need to test to see if you understand how this triangle works.
Wait.
Just a quick test, Yes. Yeah, why? No, I wrote in cursive, so I wrote that fast. Yeah. Okay, mass, density, volume. Okay, so Karen, you want to explain how this works? Okay, so there are three ways to use this, correct? Okay, so first way is if I want to calculate mass. Okay. Okay, for those that don't know how to use this triangle, I'm going to run through. When you see this line across, they are saying divide. Okay, so I'm going to put a divide sign over here. When it's side by side, it is multiplication. Correct now? From what you learned in primary school. Correct me if I'm wrong, I'm not a math teacher. Okay, so let's say we want to calculate mass. Mass equals to whatever is remaining. Density times volume. Density times volume. Okay, let's try another one. If we want density, it's over here. Density equals to whatever is left. Mass divided by volume. Follow it? Okay, let's try one last one. Volume equals to whatever is left. Mass divided by density. Is it? So for the speed one, you all write speed on top. You all wrote distance, then where's speed? Speed. Okay, so for all of you here, if this is new to you, can you write this down in your textbook so that you know the different three ways of formula? Joshua? Oh, you know without the triangle. Okay. Okay, if this is new to you, you can write down all three versions of the formula. Okay, you can write down all three versions of the formula. We only provide this formula because this is the main one to understand the theory behind it. Must it be a triangle?
The triangle is the strongest shape of the
Okay, up to you lah, what shape you want. Okay, as long as it's on top, these two are below. Okay, that's a good question. I've never asked why it's a triangle. Okay, I want to show you something here. So, based on what we have learned about the definition of density and the formula, let's look at these three cubes. do they have the same density? Do they? Okay, then which one is the densest? Can I? So you see how this definition comes in? Density is about how much mass there is per unit volume. If we just compare across the board, this is very easy to compare, right? Because all the volumes are the same, we know that the only thing that differs now is how much mass there is in each one. Easily we can say that this is the densest, followed by this one, followed by this one. You know how I can change things up to make it a bit more challenging for you? I make the volume different for each. Okay? Then you have to figure out a little bit more. Okay, shall we try? I modify the volumes now. Then you tell me which one is the densest.
Regardless of whatever element it is the density the same actually. I find that each element is different, but then everything that is like platinum will always have the same density, no matter the matter.
Oh, okay. Are you saying that if I somehow take out one atom of platinum versus one atom of aluminium, are you saying that will the density change? Okay, so the density of the object shouldn't change even if you cut it up into smaller pieces. Yeah. So for example, if I this platinum, if I were to chop it into 4 more cubes, each of those small cubes, the density shouldn't have changed. Why not, right? So let's think, if I were to chop this platinum into 4 cubes, will the density of each small cube change compared to the bigger one? The reason why it won't is because when you chop into quarters, you actually chop this mass into 4. Then the volume also has to change 4 times smaller. So if you were to take a density, it will be the same. Yes, Samuel? Yes, always asking important questions. Okay, let's practice. You are allowed to use calculator when it comes to calculating density. So let us change the densities. Let us change the. Okay, let's do a quick new theory. Let's say I have. Okay, this one has a volume of 1 meter cube, 2 meter cube. 5 meter cube. Okay. Next, this one has a mass of 6 kg. Okay. 12 kg. Okay, quickly calculate which one is the densest. Do you need calculator or can you do mental sum? Which one is the densest here?
Yeah, the last one. Last one, yeah.
Okay. Okay? See? Yeah? Okay, so how do we calculate? We take 6 kg divided by 1 meter cube. I will get a density of 6. Okay, so this is the unit. If I give you kg and meter cube, you write kg. Okay, I want to teach you a new way of writing the unit. Because now you all are in secondary school. Okay, I'll teach you. Rather than slash, can you do this now? Meter negative cube. Okay, remember, the negative means the same thing as slash. So if you write slash meter cube versus meter negative cube, it's the same meaning. But you'll find scientists tend to write, researchers next time, if you look in research papers, they tend to write with a negative instead of a slash. Yeah, actually a slash looks like you are doing another equation. So you will tend to write it with a negative q. This is the science way of writing. So negative q. What? You're sure? 10 is 10. But I'm showing you this is the more upgraded way. Okay, now that you all grown up. Okay, so this one also equals same thing, right? 6 kg per meter cube. What is this one? It's 8. Okay. 8 kg per meter cube. At first I was calculating wrong. 4 divided by 0.5, I thought it was 2. No, it's
No,
8.
that's 4 times 0.5.
Allocate density, because now I'm going to show you a challenging question. Our practical will be what? This Monday got school, right? No, next Monday is our last practical for the term. Yes. Yeah. So different people jump into water will float differently. Xavier? Oh, that doesn't affect density. Okay, yes. Okay, Isabel asked each one of us a different density. Okay, I think the only way to find out is we need to number one measure our mass, and secondly we need to somehow measure our volume, right? All about what's okay, Darren, what's your mass? What's your mass? What's your mass? 34. Okay. 34 kg. Okay, my mass is 66 kg. I can't tell if you are happy or proud. Okay, then we look at sizes. Daryl is younger than me, I'm older than him. Our size is also different, right? Is it safe to assume that our volumes are different? Yeah. So I like to think that all of our densities are different. Yeah, and very likely therefore if we both want to jump into the pool, I think we will float to different extents. Joshua? Yes. Samuel? You want what? Oh, you're asking how I never go gym, that's why I'm 66, is it? I don't know what to answer, man. Actually, 66 is considered quite light for my size. Oh, is that why you asked me why I never go gym? Oh, because I should be heavier, is it? Yes, Yucheng. What comment you want to make now? What's my height? I'm 176. See, I have it at 73. Yes, Xavier.
But humans are hollow. Some parts of humans are hollow.
Not all parts of us are
brain,
hollow.
our stomach.
Okay, I have a challenging question. I will not guess, Isabel, last one. Yeah, why not? You know, all of us one of the things that doctors can calculate, I don't know how they calculate, but it is true that our bones, some of our bones are denser than others. Have you, some people, right, they look like they're very skinny, they stand on the weighing scale to be quite heavy, their bones actually are quite dense. So all of our bones also slightly different densities. Not necessarily. Something can be very heavy, mass-wise, but the volume is very big, then it can float. If it is denser than the liquid it is in. Yeah. Yes. Why not? There are billions of us. Okay, I'll let everyone now. You can try this question by yourself or with a friend. This is a very challenging question. It requires you to use this formula a few times. Let's read the question together. I'm going to illustrate this question on the whiteboard. Do you know in primary school what an alloy is?
You put two metals and mix them together.
This is what an alloy is. You can write this down, the definition of an alloy. An alloy is a mixture of two or more metals. That's what an alloy is. Alloy is a mixture of two or more metals. You may be wondering, how in the world do I mix metals?
To make
You melt them. You melt the metals until they are liquid and you stir them into each other.
So
Yes.
maybe they got different density. Later when you harden them up, they float, right? How?
Exactly. So when you mix different metals together to form an alloy, you can affect its new density. That's what we're going to calculate here. Don't calculate so fast. No, but I won't tell you the answer yet. Okay, so let's make sense of this question together. I want you to try this out. It's a very challenging one, but it's a very fascinating question. An alloy is made by mixing 360 grams of copper of density 9 grams per cm cube. So they did not tell you what the volume of this copper is. It's a question mark. But we do know that it has a density of 9 grams per cm cube. They mixed it with 80 grams of iron. So 80 grams of iron.
metal 50.
Again, they did not tell you what the volume is. It is a question mark.
Is it 8?
It has a density of 8.0 grams cm cube.
Are you good? I got 8.
Then they mix these two together to form a new block of metal. Your task now is to find out what the density of this new cube is.
8.8.
Okay, can you do the working? Now invite someone up to do the working on the whiteboard. Okay, can you do a working out neatly? I'll let you practice working because when it comes to your quizzes next time, it helps us as a marker know whether you understand. Okay, so this is how a good working can look like. It can look something like that. Let's say you want to find the volume of the iron, of copper. This is what you should do. I don't know if you learned this in primary school. You write something like that. Volume of iron equals. Then you do your math. Then you calculate. So can you do very neat workings like that? Do different steps. Volume of copper.
Mr. Tan, how do you define neat?
How do you define what?
Neat.
If I can tell what each working is for, then I know it's neat. Okay? How do you tell the teacher what each working is for? It's okay. You can write words. Write words to tell the teacher what each working is for. I'm going to give you the sample of the first working. Volume of iron equals to
80 divided by
80 grams divided by 8.0 grams cm cube. That equals to 10 cm. Sorry? Yeah, you must write the units. Okay. How many significant figures of decimal place you need this to? Okay. Every time you are deriving something from two different units, you will leave your answer in three significant figures. Okay? Even though I know you punch calculator, you get 10, right? You leave it to three significant figures. As long as you are calculating something with two different units, okay? You leave it to three significant figures. Static, sorry, you raised that very long.
Why is the density like have the one decimal place below the
Oh, why is it one decimal place even though it's 0, right? Good question. Because of the instruments that we were measuring it with. Remember, every instrument is its own precision. So likely, why there's a 0 here is because the instrument we use to measure the mass and the volume came with these decimal places. So it's important that we leave it there. Isabel? Okay, so this is assuming that the teacher has already done all the measurements for you and they provide you the data. All you have to do is to, yes, use the calculator. But during your practical, which we will do next week, we will do all this from scratch. You will measure the mass balance, and you measure the volume in the way that you are telling me who is that measuring cylinder. Then you will do the math counter. Especially on water. Yeah, it will be. So I'll teach you how to be less messy so that you don't lose water as you drop it into the water. Okay? Yes? Okay, almost done now. Okay. Everyone got a chance to try the question yet? Try it, yeah?
I have an answer. But now I have to write down my findings.
Megan, have you tried the question? You are like me when I was in secondary school. I'll finish my question very fast so that I can draw. Okay, art is very neat. Nothing is regular. The density is what? Okay, looks like most of you have given it a try. Okay, so these are the steps before we end off today. Okay, this is what I need. This is what I need. Yeah, okay. Okay, this is what neat workings look like. How many of you in your workings you only gave the mathematical equations on the right side? Okay, so if you may I get you now from now onwards in science to tell the teacher what each working you are doing is for. For example, mass of the alloy equals to 360 plus 80. Sorry? Sure, short form also can, but you just need to let the teacher know what you are doing. Next one, volume of copper equals to this divided by this and get this. Volume of iron, this divided by this and get this. So you need to define what you are doing at every step. Yes? Where? Where's the typo? Oh, density if alloy. Oh no, I have like 20 over more papers, they will change every 5 minutes. Yes. Okay, good question. You have to write units for every number. Yes. Okay, every step that you do, you need units. But the thing is, okay, so I think as you go up the levels, the teachers won't be as particular whether you write units for here. But they are more particular whether you write units for the final answer. Okay? Yeah. But as a secondary 1 student, why we advise you to still write your units here is so that you know which ones to cancel out so that you get the correct units. Okay? Because sometimes you don't write and you forget that this is the actual unit. Okay, but the final unit is very important. Yes. Sorry? These are all the formulas just changed in a different way from the triangle. Oh, like must I write mass of this, is it? Volume of this, yes. Okay? Okay, so if you only have the practice of writing the math part down, it's important that you write the explanation at the side, may write equal to tell us what math you are doing. Yes. Yes. You haven't moved before, right? Okay. Oh, the boys. Hey, boys, you need to train yourself. Oh, so you don't like my subject, Joshua? Oh, you didn't say, but it was implied, Joshua. Okay, so oh, is it boys drink more water? Okay, B after this. Sorry? Yeah. There's not much time left also. Yeah. Okay, that's all we do today. Next time I see you will be this Friday. And I'd like to go through your worksheet, RE 3.1. Okay? Alright. Okay, we say thank you. Then we just wait for the next. Okay, thank you, class.